Hi folks, we're talking about the cloud, and there's not many terms in computing or in IT that is more confusing to people than the cloud. I think that there's a lot of problems with the terminology because some people use it to refer to literally anything that is running on someone else's server. That's in the cloud. Um, but thankfully there are some more specific meanings to cloud computing and to the cloud than that. So um, we're going to talk about the cloud and specifically around cybersecurity considerations as well. So the cloud is essentially, we're talking about cloud computing where we've got a network of remote servers that are providing some services. And some of the categories of services that a cloud infrastructure can provide can be infrastructure as a service. So that's basically a platform that allows you to host virtual machines, so run entire computers and servers within it. So for example, we might have a virtual desktop infrastructure, a VDI system, and examples of that include Overt and OpenStack. So our Overt system that we have for Hacktivity is an example of using Overt, which is infrastructure as a service. So it runs entire virtual machines across a bunch of servers. Platform as a service is where hosts access to a managed server to host software. So basically the platform as a service allows you to just run specific pieces of software and they take care of the other layers. So they'll manage like the operating system, for example, and they'll just host your software. So an example of that is Google App Engine. You can upload one specific like web app, for example, and it will host that for you. And you don't have access to manage things like the software running on the operating system. That they take care of all those kinds of details. Software as a service is where they just provide software and you use it. So for example, Google Drive, like Google Docs, Gmail, like all of that stuff where you like online version of Outlook, for example. All of that is happening on their Google's and Microsoft's servers, and you just get to experience the software that's not running on your computer, it's running on their computer. And typically it's deployed across a number of actual servers that they manage. So one of the things that this all has in common is that it uses virtualization technologies. So it's doing provisioning of resources to meet the demands that are required at the time. The virtualization also means that it's hardware independent and it uses resource pooling so that resources are assigned from a pool of resources. So for example, you could have a whole racks full of servers and those servers are busy working for various clients and they become available to whoever needs them at the time and is willing to pay to access them. For example, for third-party options anyway. So they're provisioning the resources on demand, and that gives you elasticity, which is where it's based on the real-time needs at the moment, agility and scale. So that means that a business that suddenly has a requirement to meet twice as much demand as it ever had might just be willing to foot the bill to suddenly have twice as much server capacity, and they don't need to make that investment if they're using a third-party provider. They just pay more and suddenly they've got more resources. And usually it's cost based on the usage metrics. So the more that you use the resource, the more that you pay, and quite often the way that those are calculated are quite fine-grained. So to the point where if you're not using a resource, if you're not using a VM, you shut it down because you're paying for every minute that you have it running. But what I was referring to there is public cloud, where you're basically outsourcing access to the cloud infrastructure, and typically you're using remote data centers. And it can be cost effective, especially to start up for a startup company, for example, where you don't know how much clients you're going to end up getting, and you don't want to invest in a lot of hardware. You can just basically pay to use Google or Amazon's cloud services. And there's private cloud, where you actually use those same technologies but on your own servers. So, for example, our Ava infrastructure, they run on our servers, and we've got a lot of very powerful servers that are just ours and that we manage, which has a larger upfront cost, but as a running cost, we're not paying someone else to run those; we run them ourselves. And so, in that case, we are running with a local data center and our local servers. And a hybrid approach is where you do a bit of both. So you use public cloud infrastructure and also some private cloud. And some of the information that you might want to do that is you might have some particularly confidential information that you don't feel comfortable storing remotely, so you want to keep that on premises, and in that case you might opt for a private cloud deployment. And you might use the public cloud for added elasticity. So, for example, if you meet your capacity and you need more capacity, you might be able to use an external provider to get the extra bit that you need when you need it. So, provisioning can satisfy redundancy requirements. So, we're not dependent on hardware. Service instances can be quickly created. So there's that redundancy there, that we can have multiple servers. If we feel like we need to load balance, for example, we might have a single server, and then we can have a load balancer in front of that, and then we could just create a bunch more servers if we start to meet our capacity. And cloud computing can be configured as a redundant service, and we can fail over to a caching service. Well, for example, Cloudflare are an external company that they do a lot of they have a few different services, but their main one is basically that they act as a caching service between your users. They access your website through Cloudflare, which can cache or cache some of the resources to make that faster, and they can also provide protections around DDoS attacks and other things. So, backups and the cloud. So there are services where you can have data storage as part of a remote cloud deployment, and one of the advantages of using that is it scales, and you can use it as a remote backup site. Is it reliable? Well, most are. I mean, the cloud, if you're using a service that's managed by Google or Amazon, then there's a pretty good chance that it's designed well, and there's a lot of users that they've got a lot of incentive to make sure that it is reliable. You can use things like consumer storage, like Google Drive, Dropbox, Amazon Cloud Drive. But basically, you just have a place where you can copy your files onto it. There are online backups and data storage services. So this is designed more to be a larger scale backup solution. So you've got Google Cloud Storage, Amazon S3, which is a simple storage service, Amazon Glacier. Glacier is interesting because it's designed knowing that it's hard to get stuff out of it. So it's for backing things up where you can send things into it, but if you want them out again, it could take a long time to get it back. because presumably they use tape storage and things like that. So when you try and get something out of it, it can take a while for them to actually retrieve it for you. But it's cheaper to store stuff in if you don't need to be able to get it out again as quickly. And if you're trying to do backups for an organization, then you might not need it super fast to be back, or there might be some things that you need to be able to get back quickly, and other things that can take longer. And then you could use a service like that, and it will be cheaper. There are encrypted backup solutions like SpiderOak and Mega, and other storage solutions like CrashPlan and Backblaze, where there are options if you configure them, if you choose how you configure them. But you can do end-to-end encryption where the providers don't get access to your files, because only you have the key that was used to encrypt your files, and it's sent to their servers. So that might be an important security property for you. So how do we reason about security and all of these complicated systems? Well, it can be complicated because often you've got multi-tenant systems, which means that you're sharing the hosting with other people. So you've got one server, and there are lots of clients that are storing their information onto that server. So there's identity management and access control there that needs to be managed correctly. And who has to manage that information is interesting, because you need to know what you're responsible for. Because, for example, like my website, for example, is stored on a multi-tenant system where there's other users of that system. And if I set my access control up in a way where other people, I could set my file permissions up in a way that other people that share that servers could access those files. So you just need to be careful and aware of that. And the actual hosting provider needs to be aware as well of what their responsibilities are. There can be lots of physical servers in lots of places, so you need to wonder about the security of the actual physical security. So and whether or not you even know where your things are stored in reality. So if there's a company that has lots of different data centers around the place, do you know where your information is going to physically be stored and how secure it is? Sometimes you don't. But you might still be confident because of the policies and procedures they have in place and the information that they publish. But it is something that you need to consider. The operating system, the platform it's running on, the databases, virtual networking, application security. So who has a responsibility of those things? It's something that you need to be aware of and consider. So with infrastructure as a service, you're responsible for basically all of those things because you're just deploying virtual machines that you completely manage. With platform as a service, some of that stuff is managed by the hosting company. Which of those things you need to make sure that you understand correctly, so that you manage the security of the parts that you're responsible for, while Google, for example, manage the operating system versions, for example, and patches and updates. So if there is a single security breach in a multi-tenant system, it can have a wide-reaching impact because it can hit every company that is using that multi-tenant system. And also it can be the case that if some tenants are doing things that are insecure, whether the system's designed in a way that still keeps each other user secured, for example. So you could have attacks that are actually originating from other tenants on that same server or on those same servers. And the service provider employees, do they have access to the information? What level of restriction do each of the employees at Google have, for example, in terms of accessing all the different servers that are running? Is a legitimate question that you should ask yourself. And then there's external threats and vulnerabilities as well. So there's lots of places the attacks can start from. One of the main advantages of public clouds is the cost, and it's externally managed, which has an impact on security. If you think about Google's security practices versus you running your own server as a startup company with a handful of employees, there's a pretty good chance Google are going to do a better job than you are at some of those things. Like physical security, probably Google have better things in place than you would if you were just a small company with an office, for example, and you had a server in there. Like Google's going to have better physical security in place than you would. But it's often impossible to remotely audit, or even including physically audit some of these services. So, for example, with Amazon Web Services, you're not allowed to do a security audit of, like, actually even pen test your own systems without getting their permission first and informing them that you're about to do that. And you're certainly not allowed to audit their physical security. You can't turn up and ask to be let in and look around the premises. Certainly not as a small user of their systems anyway. But yeah, one of the main considerations is that all your data is being stored and processed somewhere else on a computer that's owned by someone else. And that provider has access to all the data that you give them, in most cases, unless you're being really thoughtful about the way that you're storing and processing that information. There's privacy concerns there and around the employees that get access to that information and how it's secured. And there's legal and compliance issues. So, for example, if you're in the EU or the UK and you have some data that you're storing on a server, does that server comply with GDPR, and are they doing all the right things for, like, European laws, for example, and to protect the privacy of the customers? So one of the points here is as soon as you start using a public cloud, is things are outside of your control, and it's just, something to be aware of. There's potential around availability of services if their services go down, but again, it depends on the company, the reliability of the company that you're using, and maybe you actually end up with something better than if you're doing it yourself anyway. So there's shared responsibility, and you need to know who's responsible for which layer. So there's the application software, operating system software, the network. So is the host somewhat responsible for this layer? I guess it depends on what you have control over. There's the hypervisor, which usually the host is responsible for, and there's the physical layer. So some questions to ask when you're making decisions around cloud-based deployment and security. So, are you allowed to do security audits and penetration tests? Is that a problem or not? How much notice do you have to give? Is that acceptable? Where's the physical location and what's the security there? Is the information encrypted at rest? So when things are stored on a hard drive, for example, are they encrypted at that stage, or is it unencrypted at rest? And what about server-to-server transmission? Is that encrypted, or is the backbone communications between servers unencrypted? And that can be the case. And how is the responsibility shared? So what's my security role if we take on those services? So in conclusion, every organization has to be able to function under adverse conditions and recover from problems. So we need backups and redundancy in place. Cloud computing, as we've just described, provides a possible solution. Actually, it's amazing what's possible with cloud computing, which is, if you look at the what we have now and all these amazing services and things that are available to us on the internet, a lot of the companies wouldn't exist without outsourcing to cloud computing. And Google and Amazon host a lot of websites are hosted on those servers. but you just need to be careful when you're considering what the pros and cons are, so that you're aware of those facts. And then when your actual demand is high enough and you're using a lot of computing resources, then it might make more sense to have a private cloud where you have your own services, your own servers that you're managing. It just means that there's more that you're managing in-house. So there's lots of things to consider there. Cloud computing is, we're just scratching the surface there, really, but there's a lot to consider. And hopefully this has helped you to understand what cloud computing is and how it's related to security.